Hello one last time. This is the last problem in Unit 1 as of this recording, so let's see what they have for us. What mass of ethanol must be formed from its elements under standard conditions to release enough energy to heat 2 kilograms of water from 25 to 65? Okay, this is a two-part question, and it's the kind that in the lessons we call heat lost equals heat gained. There are two things going on. We are doing some kind of reaction that forms ethanol. And the formation of ethanol, which is C2H5OH, ethanol is made of carbon, which is a monatomic element. Generally, it's more complicated than that, but we'll pretend. It's made of hydrogen, which is a diatomic gas, and it's made of oxygen, another diatomic gas. So this reaction is going to release heat, as we'll see in a minute when we calculate its delta H. Then all that heat is going to be used to heat up some water. Warming of water. The formula that tells us how much heat comes out of a chemical reaction is energy equals N delta H. The formula that talks about the heating of water is energy equals MC delta T. And these two E's are going to be the same number. So we're going to find E on one side and then jump over and use E on the other side. Now, on this side, we don't know how much ethanol we have to find, so we don't know N. We also don't know the total amount, so we don't know E. So despite the way I kind of gestured at the left side while I was saying this, we can't start over here. We don't know enough to get anything on the left side. How about over here? We have the mass of water, 2 kilograms. We know the specific heat for water, and the temperature change is going to be 40 degrees. So actually, this side is our friend. We can actually get stuff done over on the right. Oops. I'm just going to have to erase that or... So they're starting with, we need you to heat up 2 kilograms of water, which has the specific heat of water. Again, I'm working in kilo units because that's what they gave me. And the temperature changes from 25 to 65, so 40-degree increase. Crunch that out. 2 times 4.19 times 40. And we get 335.2 kilojoules. So now we turn to the ethanol and say, all right, ethanol reaction, we need you to give us 335.2 kilojoules. We already figured out the ask, and now you've got to come through for us. So we have to finish this thing, and it's going to be 335.2 equals blah, blah, and we'll solve for our mass from there. We don't have a delta H, and we're going to need one, which means we need a balanced reaction. Let's take care of that. I probably should have done that right away, but this will be all right. 2 carbons, 6 hydrogen, and 1 oxygen. I'm just going to put a 0.5 there. And again, I'm doing these numbers to be a good boy, but you know what's going to happen when we do our delta H, right? None of these are going to end up mattering. I really don't want you to get in the habit of not balancing reactions, because that'll burn you regularly. So our delta H is C2H5OH, which is ethanol, which is minus 277.6. Minus a bunch of zeros. So our delta H is minus 277.6. Could I have doubled all this to get rid of the decimal? Sure. Then I would have 555.2, I think, per 2 moles of ethanol, and you'd get the same answer. It would just be a little more painful. So now that we have that, we can say our total energy equals N delta H. The total we need is 335.2 kilojoules equals a number of moles I don't know times 277.6 kilojoules per 1 mole C2H5OH. Notice I stealthily removed the negative here because I don't want my number of moles to come out negative. We know it's an exothermic reaction and that this is absorbing heat and this is making heat. None of that is critical to track with negative signs here. So if we want to solve for N, we do 335.2 divided by 277.6 over 1, and we get our number of moles is 1.2075 moles of C2H5OH. If they had said how much ethanol, you could be justified in stopping right here, but they said mass of ethanol. So how do we find masses? M&M. Mass is number of moles, which we just got, times molar mass. So we need the molar mass for ethanol. 2 carbons is 2402. Total of 6 hydrogens is 606. There's a single oxygen, that's 16. 8, 0, 10 plus 6, 16, carry 1, 4608 is our molar mass. So mass equals our number of moles times our molar mass of 4608. 55.641 grams of ethanol. Everything they gave us had 3 sig digs. Our molar mass was more than that. The heats of formation were all more than that. So 3 for our finished answer means we should trim to 55.6 grams. And that should do it.